Good morning, guys. Happy snow day again. I just wanted to walk you through the first part of the 9.1 notes so that when we get back to school tomorrow, we can answer some quick questions and then continue to move on. So Chapter 9 is looking at significance tests. And the first section really is just kind of going over the basics of that. The difference between a significance test and what we've been doing with confidence intervals is significance tests really, they assess the evidence provided by your data about some claim concerning the population. Like 50% of the population believe option A is the best. Something along those lines. And what we'll look at is by using a significance test of whether we should reject or fail to reject that claim. Whereas a confidence interval, that really gave us an estimate for a population parameter. It gives us a range of all possible values. So what a significance test is, it's a formal procedure for comparing observed data with a claim, which we also call a hypothesis. And we're basically doing this to test the truth about the claim. So the claim is a statement about the parameter, so your population proportion or your population mean. It's not about your sample, it's about the population. We express the results in terms of a probability, which we call a p-value, and that's going to tell us how well the data that we're finding and the claim actually agree. And so when we think about what a test does, it says it asks if sample data gives good evidence against a claim. A test might say, if we took many random samples and the claims were true, what's the probability that we would get a result like this? Okay. And so the first thing we're going to look at is just an activity. And you can find this activity link if you go to Launchpad or the book website. Go to resources and search by type. Just look for your applets. And then you need to just find the one that's called the reasoning of a statistical applet. And so this example, or this activity is talking about this basketball player that claims he can make 80% of his free throws. But people were kind of thinking he was exaggerating. So we can use this kind of as a test. So what it asks you to do is to change your number of shots to 25 and then hit shoot. And sorry, there is no way to kind of skip the animation on this one. It takes a little bit longer. And so you can kind of watch, and it kind of shows how his percentage changes over time for his 25 shots. So for this one, I ended up with 16 out of 25 making it. I have a 64% average. So if we click shoot again, we can kind of watch and see how that changes. And it asks you to keep doing this until you are convinced whether the claim is true or whether you think he actually has a lower shooting percentage. So I'm going to hit shoot just a couple more times. And so if you look at the results, and remember we talked about how probability, it's more variable in the short run, but over the long run, it really starts to approach a specific value. We'll do one more time just to kind of show you. We can kind of start to assess whether we think this claim is true or not. And so looking at my results, right now I'm at about making 52% of my shots. If I show the true probability, you can see that 80% was the claim. Here is the actual probability that my sample is showing. And so we can see that there's probably a good chance that his claim is untrue. And then it asks you to walk through this with another shooter and ask you a couple of questions. And so you can kind of play around with this if you would like. But the basic idea of a significance test is that an outcome that would rarely happen if a claim were true, typically that's good evidence that that claim is not true. So we kind of always go in assuming that the claim they make is true, almost like innocent until proven guilty. But if you get a really low probability, that's telling you that it's pretty rare that this would happen. That's kind of evidence against your claim. So when we are stating hypotheses, the claim tested by the statistical test, that's called the null hypothesis. And we labeled that just H sub 0. Okay. This is, like I said, this is the claim you're making. Often the null hypothesis is called the statement of no difference, or that the claim is true. The claim about the population that we're trying to find evidence for is what we call the alternative hypothesis. That's age of A. And so, for example, in our free throw shooter activity, the claim is that his proportion was 80%. So that would be our claim of no difference. We're assuming his claim is true. We thought that he actually made less than that percentage of his shots. And so our alternative hypothesis that we're trying to prove would be that the population proportion is actually less than 80%. And so this is what your hypothesis statements would look like. You also always want to state, like, what does P actually stand for? So for ours, we'd say P was equal to the long run proportion of free throw shots that he made. And so again, the hypothesis is always going to be equal to a value, okay? The alternative can come in one of these forms. It can be less than that value, it can be more than that value, or it can just be not equal to that value. These are what we call a one-sided test. This one, if we're just saying it's different than what's claimed, it could be less than or greater than. This is what we call a two-sided test. Okay? But it is important to remember that your hypothesis is always referring to a population, not the sample. So you should always be using your population variables, just P or mu, not P hat and not X bar. Those are from your sample. So your hypothesis should always be about your population. So if we look at this example, and this is really kind of the last example I'd like you to look through today. It says a high school junior running for the student body president claims that 80% of the student body favors her in the school election. Her opponents believe this percentage to be lower. Write the appropriate null and alternative hypotheses. So you always want to state what the parameter, what P actually represents first. So in this case, that would represent the true proportion of the student body that actually favors Sally for president. The null hypothesis, or basically our statement of no different from the claim, is that the population proportion is 80%. What we're trying to prove is that we actually think that proportion is less than 80%. So when you're asked to write your appropriate null and alternative hypotheses, it really should include all three of these. And so here's where we're going to kind of stop the notes. I did post some homework problems on Canvas. I would like you to try to get through at least question 11, possibly 13, but question 11 would be great. And then we will answer any questions over the notes. I've also posted a copy of the notes on Canvas. We'll start tomorrow by answering any questions over the notes, and then we will kind of move on from there and start talking about how to interpret p-values. We'll see you guys tomorrow.